And as you can see, I'm going to take the hand driver. I'm going to engage it. So that's what the Noble Active implant looks like. It has, I don't want to touch the implant because we never touch these implants with the hand. The implant has the Tyenite surface, which we're going to talk about later, which is a modification of the surface to again promote faster healing. It has a very unique groove system that is designed to promote stability. These implants are very stable in the bone initially through mechanical stabilization, allowing for immobilization so that the bone will heal around the implant and ultimately fuse to the implant. So what I'm going to do is I'm going to place the implant. Hold on. Just with some finger pressure until I can get some stability. So it's now fairly tight. Give me a little bit of water, please. And again, Thierry's not touching the implant with the suction. Now what I'm going to do is go back to the hand wrench. Open the bone. I'm actually going to have to remove this, it's in my way. So you see this, if I pull the bow, I'm already at 70 Newton centimeters. That's stable. That's how stable these implants are. They're unbelievable. But what I want to do, I don't want to exceed more than 70. So I'm going to take this little arrow here, reverse it, make sure this little neural knob is tight, and I'm going to back up the implant a little bit. And now I'm going to turn it back. I'm reorienting the implant to go more vertically in fresh bone. Give me some water, please. And the whole time I'm pulling just the bow so that I'm safeguarding myself not to go past 70. Now I've hit pretty much bottom, so I'm going to again reverse it now. And this allows the implant to cut in the bone. And you can see how much easier it is. So again, I'm hitting bottom. So we're going to back it up again. Now I'm going to go in a forward motion again. Here, can you just hold this? Patient's actually feeling that a bit because he's feeling the pressure, and I'm at 70 Newton centimeters. But I'd like it to, these implants can be placed subosseous because they're all platform shifted, and we'll explain that afterwards so that we can connect our restorative components without worrying about the bone interfering. So these implants can go deeper. And I think we're there. That implant is now rock solid, and we're going to be able to load it up with an immediate temporary. So what I'm going to do is just clean off just a little bit of the bone here that I don't want. There's a defect left in the bone buccal to the implant, where the remnants of the buccal root is. Apically, that area is filled. So if I go down the buccal aspect of the socket here, I'm only going down a few millimeters because I know that the implant has pushed the bone towards the buccal when I reoriented it. So here's our implant, and what we're going to do is we're going to put some bone grafting material into the void space, the empty space buccal to the implant. Then I'm going to connect a temporary component to the implant, and we're going to then make an immediate temporary tooth. We're going to use this material. It's called Connexus from A-Cell Connexus, distributed by Cytogenix. It's demineralized bone in a putty form. It has a reverse phase medium, and it's really what I consider one of the best bone products around. Any bone product that you're going to use should be ideally turning over as quickly as possible into the patient's own bone. So graft material is not something that we want to stay there. We want the patient's own bone to end up around an implant. An implant will only integrate into bone. It's not going to integrate into this stuff. So what this does is it acts as a filler around the bone, around the implant, preventing any inflammatory cells and any infectious cells from coming in, and at the same time acts as a matrix for the body's own cells. In other words, it's osteoconductive to come in, replace it, and then the body cells, the bone cells, will actually grow in there and fuse to the implant, and the implant will become histologically integrated in the bone. And actually, I'm going to connect my temporary component first. This is the temporary abutment. Okay, it's prefabricated. We use a multi-unit driver to grab it, and it has a screw that's going to go into the implant. It has a conical shape which mimics all of the abutments in the noble active system to allow for the biological healing that we want to get on top of the implant. But we are trying to create the natural gingival architecture around the implant crown, so that actually these implant crown restorations in their final state are not flush fitting with the head of the implant. There's this apical, this coronal taper that allows for a greater tissue volume development, so that you actually have a thicker tissue around the neck of the crown restoration. So these are just put in by hand, And that's what the temporary abutment looks like. And as you can see, that's pretty good placement. That's almost right in the middle of the extraction site. So you can see what I'm referring to is the design with this 3 millimeters of taper from the head of the implant to the base of the abutment. And that's to allow for soft tissue development. So we're going to get an increase in soft tissue volume around the neck, and then the actual crown will finish to this point here, because the final abutment will be analogous to that. And we're going to just fill the bone in here, and that's it. And we're going to take the connexus, we're just going to squirt it into this space here. I'm basically going to pack it around, and we're just going to overfill it a bit. And that's it. Then we're going to suture it. On top of this metal post, a little white sleeve from the temporary here. There's one more piece that you'll see actually in a second. This is what adheres to the acrylic. So this goes on top of the metal post. And now we're just going to suture this. And I've got a little bit of excess tissue, but that's okay because I want to have as much tissue as I can to cover the graft. Now for those who don't want to do a chairside temporary, you could actually take an impression of the implant at this stage, give it to your lab, and have them make a temporary. Just be careful, section. But the most important thing right now is that I just want the tissue to cover the graft material, so it's not going to go anywhere. And usually you'll get a little extrusion of excess grafting material, which is fine. Just suction that away. Open. They should ban beards from dentistry. And I'm not worried about any excess tissue. I just want to keep that graft covered. And the excess tissue you'll see will just remodel. Sorry. The excess tissue will just remodel on its own. I'm just going to put one more suture in, and we're all done. So there you have it. You've got a really nice implant, well placed, mesial-distally, buccolingually, and nicely sutured. Say pretty good closure, maybe 90% primary closure, so this graft area here is protected, and nice and dry. And we're going to make a temporary crown on top of this using our crown shell, our crown former that we had made. Implant surgery, you'd be using a surgical guide stent. In this case, I have a stent made, but I didn't use it because I had my socket site, so it would really be redundant. I know where I have to go in terms of the socket site, and I was manipulating the placement by hand using the properties of this implant system. What we're going to do, though, is use the surgical guide stent that we had made as an acrylic shell, or as a shell to hold the acrylic, which will be luted to this white plastic piece for making our temporary tooth restoration. This is the Implant Mentor resonance frequency measuring device. These are the little magnetic pegs, and what I'm going to do is I'm going to unscrew the abutment. I know that this abutment was torque challenged to 70 Newton centimeters. Between insertion torque and torque challenge. Insertion torque is just the amount of rotational energy that either the machine or your hand is exerting when you're placing the implant. But it doesn't tell you anything about the ability of the bone to resist displacement of the implant. Torque challenge is when you're actually testing the bone for any type of movement of the implant. And we know that any implant that can be placed at least 35 Newton centimeters can be considered for immediate loading. I'm a little bit more conservative. I like to have a torque challenge of at least 40 or 45 Newton centimeters before I'm going to put on an immediate temporary and have any type of function with it. In this particular case, when I placed this implant and I was pulling that bow is measuring the amount of torque that it would take to move the implant, and I could pull that bow all the way up to 70 Newton centimeters. So this implant is extremely stable, and I expect that when we do our OsseoTel reading that we're going to get a very high number. So they come packaged. They're called Smart Pegs by OsseoTel, and there are specific pegs for every single implant on the market. So it's not just for Noble Biocare implants, but for every other implant. Each implant diameter and each implant manufacturer will have, there will be different pegs for those implants. So I'm using a Smart Peg, which is specifically designed for a regular or wide platform Noble active implant. The restorative table for the wide platform implant is exactly the same as the restorative table for the regular implant. So I'm just going to unscrew this very quickly. And then I'm going to insert this. And you do this finger pressure only. You don't want to put more than 5 Newton centimeters of pressure. And you just push this button on. And all you want to do is hold this open